a rechargeable phone, a rechargeable laptop, a rechargeable keyboard, a rechargeable car, the rechargeable batteries that power our day-to-day lives wouldn't exist without a simple chemical reaction, which allows lithium ions to move between the electrodes when batteries are charged and discharged.
But they do not last forever. They typically reach the end of their service life and need to be recycled to recover the valuable materials in them, materials like lithium, cobalt, nickel, manganese, copper, and other types of materials. My name is Ikenna Nlebedim, and I am a scientist in the Division of Critical Materials at Ames National Laboratory.
Sourcing critical materials for batteries can be complicated because these materials are often found in very few places on Earth. Also, these materials are often found in quantities that may not make economic sense to try and obtain. If we are better at recovering the materials we already have here in the US, we will become less reliant on these materials coming from elsewhere.
Currently, three main approaches for recycling batteries include the pyrometallurgy, a process which uses high heat to extract metals and other materials; hydrometallurgy, which typically includes water-based solutions of mineral acids and other chemicals; and the more recent direct recycling methods. Unfortunately, the drawbacks of these methods have limited the environmental and economic sustainability of recycling lithium-ion batteries.
But recently, Ames National Lab has been working on a more worker-friendly and cost-effective way of recycling lithium and other valuable materials found in lithium-ion batteries.
We call it the BROS technology, which stands for Battery Recycling and Water Splitting Technology. The technology uses water as the only solvent, eliminating the need for hazardous chemicals such as mineral acids. This feature of the BROS technology enables operational safety and minimizes environmental contaminants that would otherwise be in the process waste.
Hello everyone, I am Anirudha Karati and I am working as a postdoctoral researcher at the United States Department of Energy's Ames National Laboratory. I'll walk you through the BROS technology today. Prior to the disassembly of the lithium-ion batteries, we discharge it such that it is safe to cut it open. Once we have the anode and the separator, now what we do is we dunk the anode and the separator in water. We then bubble carbon dioxide through the solution. In this process, what happens is the lithium in the solution gets deposited as lithium carbonate, which we can filter and collect it out. And in the process, we also get the graphite, which gets kind of peeled off of the copper electrode, and we can separate the copper and the graphite. With this, now we are able to recover all of these materials. So the entire BROS technology starts with lithium-ion pouch cell. After we disassemble, we are able to recover the aluminum casings, the cathode active material coated on the cathode, the copper foil, the separator, and finally the valuable products, that is lithium carbonate and graphite.
Recovered materials go directly back into the manufacturing process and can be used in headphones, cars, medical devices, or wherever it's needed.
We know that lithium is integral to our future technologies, but we also know it can be difficult to obtain. This means finding more economical and sustainable ways of recovering lithium is very important. There are advantages and disadvantages to different methods of recycling lithium. The BROS technology provides the advantage of being environmentally friendlier than the ones used in the past and could be more economically profitable when deployed in the future.
Every end-of-life battery represents a chance to reinforce the supply chain for future batteries. The BROS technology is designed to turn this potential into reality.